All right, beginning with example 8. So one important fact about in this word problem is that our function's always positive or 0, so it's at least non-negative. Okay, that can tell us a good relationship between the integral and the area. All right, so we're going to approximate this using numeric methods. One way we could do that is by using rectangles. All right, and so one thing you should check the difference between all of these. Okay, so the first couple are 0.5. That doesn't mean that all of them are going to be 0.5. It's worth checking that. Okay, it doesn't take you that long. Check it out. All right, so in this case, it happens to be all equal intervals. All right, so for us, we can approximate that integral. I choose left because I like it. I don't know. You could pick any way because it doesn't tell you something specific. I'm going to use 6 left-handed at left endpoint intervals here. So 1/2 times 2 plus 4 plus 6 plus 7 plus 4 plus 1. All right, so that includes all 6 there. 1/2 times, that'd be 10 and 10, 24 equals 12. All right, or we can approximate it if you wanted by right-handed intervals. So that would be 1/2 times, this time 4 plus 6 plus 7 plus 4 plus 1 plus 5. All right, and if you add that up, 27, and so that would be 13.5. Or you could even approximate it with a midpoint, but this time we could only use 3 subintervals. All right, because these would be the midpoints here. So it would be 1, this time it would be 1 actually, right? 1 times 4 plus 7 plus 1, which equals 12. Or we could even approximate it by a trapezoidal. So it'd be 1/2 times 1/2, and it's important to show what you're thinking. Don't just put 1/4 on your paper. It's 1/2 times the width or the height actually of the trapezoid, and then it'll be 2 plus 2 times 4 plus 2 times 6 plus 2 times 7 plus 2 times 4 plus 2 times 1 plus 5. All right, and if you go ahead and simplify that, 1/4 times 51/4. Oh wait, no, it ends up just being 51/4, which is about 12.75. And if you recall from stuff that we've done before, we could have approximated the trapezoidal by taking the average of the left hand and the right hand intervals here, which would have been 12 plus 13.5 over 2 equals 25.5 over 2, or 12.75. Okay. So now we didn't answer all of the parts of the question. So we approximated it using numeric methods, and we showed the approximation by that squiggly sign. Do these represent the area? This would be yes, that they do represent the area, and that's because of this fact. The function is always non-negative. And then the last step, also approximate f prime of 1. We can approximate that by, now since there are 3 different ways that you could set this up. Let me go get a highlight for this. All right, so this is where we're trying to approximate the derivative here. Okay, so in order to do that, we can either look at these 2 points, okay, because they're equal distances apart. We could look at these 2 points. Oh, that makes it look bad. All right, let's not do that. We could approximate these 2 points, right? Or we could even, if we wanted to, do these 2. All right, let's go back to the normal pen here. So those numbers would be, we could either do 7 minus 6 over 1.5 minus 1, and don't just write the answer. Show that difference quotient. Show what you're thinking. All right, if you want to get a decimal for that, you can. All right, but you don't have to. You could just leave it numerically. Or we could do 6 minus 4 over 1 minus 0.5. Or you could do 7 minus 4 over 1.5 minus 0.5. All right, so it's important to show that difference quotient. All right, and let's try another one. Similar kind of thing here, but it's important to look at your limits. So we're trying to approximate from 1 to 8. So that means we have extra information here. Just get rid of it. We don't need it. All right, using numeric methods, all right, do these represent the area? So we're going to approximate this using numeric methods. And it says methods, so I'm going to do more than one. All right, L4. This time, let's check. This is a difference of 2, difference of 3, difference of 0.6, difference of 1.4. So they're not the same. We have to show each rectangle. Okay, so this will be 2 times 3 if we're using our left-hand endpoint. All right, plus 3 times 3, plus 0.6 times 1, plus 1.4 times 5. That'll give us our left hand. If you want to approximate that and get a decimal, go for it. All right, for the sake of time, I don't want to, and if this is a free response question, you don't have to either. All right, or another method would be the right hand endpoints. So this time it's going to be 2 times 3 plus 3 times 1 plus 0.6 times 5 plus 1.4 times 8. We can't really do the midpoint here because we don't have equal distances. We don't have enough information to really do that midpoint. We could do trapezoidal. We could do that by either setting it up. Okay, so 1/2 times 2 times 3 plus 3 plus 3 times 3 plus 1 plus 0.6 times 1 plus 5 plus 1.4 times 5 plus 8. We could do it that way, right? Or you could also approximate it by L4 plus R4 divided by 2. Okay, and put the numbers there. Now, it's asking, do these represent the area? This time it's no, because we don't know the range of f of x. It could go negative, okay? It goes from 3 to 1, so we don't know. It could go from 3 to -2 to 1. So we can't assume it's the area. And also approximate f prime of 7. Okay, this isn't like last time. We can't use multiple things. 7 is in between these two. All right, so this is the only thing that we can use to approximate it. So we'll do 8 minus 5 over 8 minus 6.6. And again, you kind of get a decimal if you want. And that's not the exact f prime of 7. We're approximating, so we're putting those squiggly equals. All right, let's do maybe one more. Sketch the region corresponding to each of these, then evaluate it using a geometric formula. All right, so the first one, this one's pretty easy. This is y equals 4 here. Anytime we have a constant, it's pretty simple. And we're going from 1 to 3. We want this area. All right, so this is simply going to just be 2 times our height is 4, which is 8. All right, and yes, this one does represent the area. We don't have any parts that go underneath the x-axis. All right, let's move on to, let's pick this color. X minus 2. It's going to look like this. And we want the area from 0 all the way to 3. So let's say that's 3. This is 0. It's crossing here at 2. I didn't draw that quite to scale. That's all right. So in this case, we're going to have 1/2 times 2 times 2 for this area. Okay, that area then would be 2. This one, we'll have 1/2 times, what is that, 1 times how high up does that go? That would be 1. So that would be 1/2 this time. All right, so the integral, remember, if it's underneath, we put a negative. -2 plus 1/2. And you could leave it like that. If you want, you could write -3/2. That does not represent the area. The area instead would be 2 plus 1/2. Okay, if you're curious about that. Let's do this. All right. Hopefully you do know what that graph looks like. If you don't, think about it like this. 36 minus x squared. If we square both sides, y squared equals 36 minus x squared. Put the x squared on the other side. X squared plus y squared equals 36. This is a circle centered at the origin. Okay, with a radius of 6. So that's 6, 6 there, another one. All right. We're trying to find that area. That's the area of half of a circle. So 1/2 times pi times r squared. So that is our integral is equal to that, or we could say, if we want to simplify, 18 pi. And then yes, that does represent the area because there are no negative parts. Okay, for the last one, hopefully you remember what this graph looks like. So we have part of it over here and part of it over here, and we're going from -1 all the way over to 4. So even though our function isn't continuous, it doesn't mean that it's not integrable. All right, it is integrable here. This area for this part is 1 by 1. That's just 1. And this area is 4 by 1, or 4. So if we're going to show this evaluation of this, you want to actually write this, -1 plus 4. Don't just jump to 3, because they want to know, where did the 3 come from? Even though this is 1 and this is 4, don't assume that anybody would know how to get there. You just need to show what you're thinking. And this integral does not represent the area. Instead, the area would be 1 plus 4 or 5.